9.3, finding special products of polynomials. This is an extension of 9.2 in the FOIL method. So let's start by doing a quick little review of our FOIL method. FOIL, first, outer, inner, last. First, outer, inner, last. So if I do one, like example 1 down here, if that is 3x plus 4 squared, what that means is that it's 3x plus 4 squared means that it's times itself. So let's do another one, 3x plus 4. So the FOIL method would have you taking first times first, 9x squared, and then outer would be 3x times 4 is 12x. Inner would be another 12x. And then the outer, 4 times 4 is 16. And then, of course, you would add your like terms, and that's where your 9x squared plus 24x plus 16 comes from. That's where we got that at. Now, this is having you do just like a little shortcut, because it's going to work this way every time. Whenever you have something that's times itself, that you will end up, this middle section right here will be the same, because it's these two and then these two. So those are going to be the same. So what they're saying is you can kind of even do a shortcut, as if FOIL wasn't shortcut enough. You can kind of do another shortcut to say, okay, if you square the first, if you square this one, you get this. And if you square the last one, you get this. So now the only other shortcut is you know you're going to end up with two of these, which is these two times each other. The 3x times the 4 times each other. So then you can just take those two times each other and double it, since you knew you were going to have two anyway. So that's basically what this pattern shows you. Square the first, square the last, multiply them together, and then double it. So 9x squared plus 24x plus 16. Let's try one more here down here with B. So 5x minus 2y. 2y. Again, let's not use the FOIL method. Since you know that this is being squared and it's this times itself, you can use this new pattern. So you can square the first. 5x times 5x is 25x squared. Square the last. Now this is a negative 2. So negative 2 squared is a positive 4y squared. Again, you know you're going to multiply these two together, and that would be a negative 10xy, but you've got two of them. Or you would have two of them if you use the FOIL method. So minus 20xy. So 25x squared minus 20xy plus 4y squared. All right, using this new pattern, let's do these few at the bottom. Square the first. Multiply these two together, 3x, and then double it, 6x. Square the last. Square the first, 4x squared. Multiply these two and double it would give us plus 4x. Square the last. Square the first, 16x squared. First times last would be negative 4xy, and double it would be negative 8xy. And then square the last, plus y squared. Last one. Square the first, 9m squared. First times the last will be 3m times n. So 3mn and double it would be 6mn. M, n, and square the last. So again, as if the FOIL method wasn't short enough, You now have something to make it a little shorter. The only thing, just like the FOIL method, the only thing you could use that on are binomials, multiplication of binomials. The only way you can use this is if it happens to be a binomial times itself. So just one more restriction, but it is a little bit shorter and easier to use. So feel free to do that at any time the situation presents itself on there. All right, next one. Page 570. The sum and difference pattern. So this is, it's kind of the same. I mean, if you look at this, it's got x plus 2. And then over here it's just x minus 2. So it's kind of squaring itself. The only thing is that it's not exactly the same because the signs are different. Well, using the FOIL method, what would happen? If I did, yes, x squared will still be there. The outer term, yes, that will still be there. Okay? But this inner term, those are the ones that get it. So x times x, that's our x squared. X times a negative 2x. Negative 2x. 2 times x. 2 times x is a positive 2x. And then a 2 times a negative 2, that's where a negative 4 comes from. But what will happen with these center ones is the same thing that will happen every time. These two center ones right here, because one is a negative, because one is a positive, they will cancel each other out every time, leaving you with just that. So the sum and difference pattern is yet something even shorter that says, okay, well, if I know that the two things in the middle are going to cancel out anyway, well, then I'm not even going to worry about them. I'm just going to square the first. And then if I multiply the last, and I can't really square the last, notice because this is a minus 4. So let's just say this. Instead of squaring the first, let's just multiply the first, and then we multiply the last. So FOIL, which is first, outer, inner, last, we know that these outer and inner, when multiplied together, they're going to cancel each other out. So now really what you have to do, if you know that it's a sum and a difference of the same thing, has to be exactly the same. If I had a negative 2x and a positive 3x, that wouldn't work. It has to be exactly the same. So now all I'm going to worry about are the first and the last. So x times x, x squared. 2 times a negative 4, negative 4. So my first term and my last term, and that would be my answer. So, some practice on this. Example 2. T plus 5 times t minus 5. Well, these are the same except for one's a plus and one's a minus. So I know that those two are going to end up canceling each other out. So I've got t times t is t squared. And a 5 times a negative 5 is minus 25. Okay, t squared minus 25. 3x times 3x gives me 9x squared. Y times a negative y minus y squared. And that is that one. Easy enough, right? All right, so practice on these with 5, 6, and 7. Number 5. They are the same. One's a plus, one's a minus. So first term's x squared, last term's minus 100. First term's 4x squared, last term's minus 1. First terms would be an x squared minus 9y squared. Okay. And that's the bulk of the lesson as far as multiplication of polynomials. The only thing that they have that I do want to at least introduce to you, using something, like if I just ask you in your head, multiply 26 times 34, kind of hard, right? But if you notice that this is almost 30 and this is almost 30, this is 40, this is 4 away from 30, as is this. So 26, if we rewrite that as 30 minus 4, and 34, if you rewrite that as 30 plus 4, now, doesn't this look like this? Okay, has the same terms in the front, but one's a plus, one's a minus, so what do? You know that you can square the first, so 30 times 30 is 900, and then negative 4 times a positive 4 is minus 16, gives you a shortcut into multiplying that for 884. Let's try another one. Let's say it's 17 times 23. Notice that they are both 3 away from 20. So this could be rewritten as 20 minus 3. This could be rewritten as 20 plus 3. Now we can use that same sum and difference pattern. Multiply them together. 20 times 20 is 400. Multiply those together, you get minus 9. So 17 times 23, 391. And if you don't believe me, you can just get out a calculator and check it. So if I have 23 times 17, 391. And I know at this technical age, a lot of you wouldn't say, oh, let me just get out a piece of paper and multiply that. But maybe if you can even kind of do that in your head, you could probably get this done faster than this calculator come up, or faster than you can get your cell phone out of your pocket. So that would be one option for you. Okay, and that is 9.3. Good luck.